Today we will be starting binary search and answers section in this driver sheet. So the first problem is on finding a square root of a number in log n. So here is the question. So yeah, basically we just need to find uh, we need to find a square root of a number provided by the user. So we can one of the brute force way we can do is we can have an variable, and for each variable we will have a count, and we will just find the square root of the number in a loop. Suppose we have a loop till the size of the to the number of, what do you call, till the end of the number which is provided. So suppose we have a number of 25, and the loop will go till 25, and we'll have a number. We will square it every time and check whether the number is equal to x or not. If it's not, then it will increase, go for the next time. When it finds it, then it exits the code. And also, whenever the value of a square is greater than the x, it will stop before the, what do you call, it will just stop after that iteration, because we found the lowest number which is nearest number to the square root of that number. So there's but it follows a, no, but it has space complexity of the order of 1, but the time complexity will be big O of n, which is not an optimal solution for this problem. Another approach what we can do Another approach is solving through binary search. Will We will implement two pointers method in the binary approach, where the low is 0 and the high is x. So I will find the mid of the pointers, and will compare it, if it's and square the number, and compare it with x. If it's lower than or equal to x, then I will update the value of high to mid minus 1, and if it's lower than x, we know that the number is still available in the upper half of the the numbers. So I will update the low equals to mid plus 1. I'll just solve this question right now. Public int binary search int x. So int low equals to 0, int high equals to x. Now I'm going to create a while loop till low is less than or equals to high. After this, I'll create a mid, which will, as we can have a number a lot greater than, which are close to integer max value, that can cause an issue with calculating the value of mid. So we will use this I minus low by 2, and now we need to find the square of this number. Mid square is equals to mid, and we need to convert it into long so that it does not exceed the bytes long. Mid star mid, yeah. So now I found the mid square. I'll check whether if it's greater than or equals to the less than or equal to x. If it is, then I will update the value of I need to take a value as well, answer as well. So answer is equals to equals to 0 is equals to mid, yeah, and I will update the value of low equals to mid plus 1, or else I know that it's greater, right, greater than the value of x, so I can just update the value of high equals to low, sorry, mid minus 1. I will return my answer, and I will just use the return binary search of x. Yeah, it works now. Yeah. The problem is done now. Okay, drivers. We need to find okay, we'll go to the question again now. Give two numbers n and m, find the nth root of m. The nth root of a number m is defined as a number. Okay, I don't understand. So in this solution we need to find the nth root of the number m. For suppose the m is 27 and we need to find what number multiplied to itself by 3 times gives the number. So in this situation 3 times 3 and 3 again gives us the value of 27. So similarly we have to find the nth root of a number. One of the ways we can do is by using linear search. We can use the we just have to find the element if it's greater than or lower than, I mean we will start from 1 and go tell the number of n which is given. So in case of 2, we'll just repeat it by um, so 2 into 2 into 2 into sorry 2 into 2. So in this case we need to find uh, yeah, we are doing this for every number. We are trying to, if the number exceeded, if the number is equal to m, then I will return the value of 2. And if it's not, then if it's suppose 3 into 3 into 3 into 3 is greater than m, then I will stop my loop and then I'm just gonna return the value of -1. So this is the way we can do, which will have an iteration of around order of n square. There's another way of finding a nth root of a number, which is called as I'm not sure. Okay, so it is called as something. Wait a second. Exponential solvation. So something similar to this. So where we can reduce the number of iterations by the power of we can see that instead of going to every single iteration, we are just checking whether if it's greater than or equals to that particular number. For suppose I will explain in this way. Suppose we have a number 24 and we need to find the nth cube of a number. So suppose, yeah, we have a number 2 to the power of 10. Okay, we need to find the value of that. So the easiest way we can do is, instead of multiplying it by 10 times, we can just we can make it as 2 square into power of 10, power of 5 by 2, 10 by 2. So now we have 4 to the power of 5. Now we are decreasing our calculation in the similar way. So now that we have it, if it's in the odd number, what we can do is we can just multiply 4 into 4 and we'll add it into the answer. And what we can do is 4 to the power of 4, and 4 square is 16, and then 16 square. So in this way we can implement finding the power of a number with the given exponential value. As you can see, what we are trying to do is we are checking if the value power is odd, then we are adding it into the answer, and then we're decreasing the value of power. In a similar way, if it's in even, then I'm dividing it by half because I'm adding the base into base. Base equals to base by squaring it basically. So that reduces the iterations by log n to the log 2n iterations. So that's a bit optimal. We can apply it to the brute force way in the linear search. Another way we can do is by using linear binary search in this situation as well. So I'll just explain it while going through the problem solution. Going through the solution. So let me just create int search int mid comma int n comma int n. So what I'm going to do is I will check if the value of mid is is greater than or equal to the provided number m. So for that I just need to form a loop where int I equals to 1 and I less than or equals to n I plus plus. Now right now I need to create a value into val 1. Yeah, so for every iteration I will just add the value of val equals to val into n, sorry not n, mid. And if val is greater than what do you call mid, sorry m, then I'll just return 2. If it isn't, then I'll check the condition. If val is equals to m, then we can just return 1, or if it is not, then return 0. Now we need to, we'll just uh, follow the basic, the general binary search rule. Int high will be our m because that's a maximum limit we can have. And now for, I'll just save the answer val mm, val, yeah, I'll just use val for, sorry, while low is less than or equals to high. What I can do is I can hmm I can add the value of low plus high by 2. And after this I have completed that, and int int mid equals to low plus high by 2. And now I will call that function where I can store the value of the, whether if it's right or wrong. Int okay, I can just use something like mid n, nth equals to search of mid comma n comma m. And now we can check whether if mid n is equals to 1, then I can just return the value of mid. If else if mid n is equals to 2, then I can just as mid nth value is 2, which means that value is greater than m, then I can just update the value of high, so that it goes, we know that the lower values from the mid can store the value. So I can just high equals to mid minus 1, and else low, if it's lower, then I just need to increase the value of low to mid plus 1, because we are going to the second half of the implementation. And then I can just return minus 1, because if it's not present in the array, then that's going to return minus 1. Hmm. Okay, I think we need to take a long value. Okay. Hmm. Yeah. So yeah, that's it for this problem. We'll check it off as a. We'll check out this one. What is this problem? Coco loves to eat bananas. There are n piles of bananas. The ith pile has piles I. Okay. Bananas. The guard have gone and will she come back? Okay. Coco and decided bananas per hour eating at K. Speed of K. Each hour she uses some piles of bananas K. From the bite of the banana is like she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all the bananas before the guards return. Return the minimum integer k that she can eat all the bananas within h hours. Okay, so I need to find how did they get the value of 4. So 3 plus 6 plus 7, I can just check 3 plus, sorry, 6 plus 7 plus this 11 is 27, right? 27 divided by 4 should be, sorry, 8, we should divide it by 8. 27 divided by 8. So yeah, in 4 hours, I mean it should be 4 where you can eat 4 or more bananas. Hmm. So we need to find the slowest possible speed in where Gogo can eat all the bananas in the given time. Okay. Hmm. I'm not sure. Okay. I mean, the easiest way is to add all of them and 30. So in this situation, where 30 plus 11 plus 23 and 4 plus 20. So it will be 7, sorry, 8, 8 and 1, 2, 3, 5, 5 plus 3, 8, 88. 88 divided by 5. 5 on your. Okay, so in that particular hour, she can. Okay, so each hour. In the fifth, 38, right? 7. 18, right? She can just have 18 bananas. Eat 18 bananas, which will pile up. I still don't understand the question. I think I will come back again. So yeah, what I did here is, as we know that uh, the maximum amount of the I mean the maximum amount of bananas Coco can eat is the highest piles. So it will at least eat 4 hours. It will take at least 4 hours to finish this. So but we need to find the minimum amount of bananas that she can eat. So to do that, we will just create a loop from 1 to the maximum amount of maximum pile, as I have done that. So I'm storing the value in the high and low. Later I'm in the while loop, I'm taking the value which is divided by the uh, mid. I'm taking the value, sending the value and divided by everything. So for in this case, the value in the first iteration, the value of mid will be 6, and I'm checking whether 6 is so how long is it taking. So 3 by 6 equals to 1, 6 by 6 equals to 1, 7 by 6 equals to 2, 11 by 6 equals to 2. So the total amount of hours will be 6 hours. But is it the lowest amount of bananas she can eat too? So we can just improve the value of high equals to mid minus 1 in this situation, and we have stored the value of answer as well. And now we'll check again. Now we have 1 and 5, and the mid value would be 3, and in this case 3 does not satisfy the solution, so hence it will be greater than h. So in that case we are increasing the value of low to mid plus 1, which will be 4. Now the value of low is 4 and value of high is 5, and when we take the mid value will be 4, and um, after using that we can just so now in that situation our condition satisfies as well, and we found the lowest value. In this case it goes into this, and whenever the loop ends we are just going to return the answer. I think that's it for the day. We are finished. We are done with the problems for the day.